Dr. David Moliterno, and I'm from the University of Kentucky, joined today by a special guest, Dr. Hiroshi Ito, who's from Osaka, Japan. And we're going to be discussing his paper, which is coming out in the Journal of the American College of Cardiology's Cardiovascular Intervention Journal. So Dr. Ito, a very nice paper. Congratulations. Why don't you give the viewers some sense of background, some information on why you took on this study?
Thank you. There are two pathological mechanisms of microvascular dysfunction in the patients with acute myocardial infarction. One mechanism is capillary obstruction. It's a typical no-reflow phenomenon that causes perfusion abnormality. One other mechanism is microvascular emboli that can be accelerated with coronary intervention. We want to differentiate these two mechanisms. That's the background of this paper.
So fantastic, and you were one of the first persons to describe the no-reflow phenomena years ago. So on one hand, we've got the possibility of microvascular dysfunction, and on the other hand, we have embolization. So what things did you do? I know you had two phases to your study. You started out in an experimental model and then went into humans. So tell us about the experimental model. What did you do?
We'd like to know the potential of Doppler guide wire to detect embolic particles, and that can quantitate the embolic particle. For this purpose, we conducted the experimental trials. Experimental trials says that Doppler guide wire can detect the particle greater than 50 micrometers that can occlude small arteries and arterioles, and that can quantitate the amount of embolic particles. That is very important point. Therefore, we can quantitate the embolic particles in patients with Doppler guide wire.
So it makes sense. So you create like an artificial circuit, and you're putting particles in of different size. I think 15 was the smallest, and you couldn't see those. And then you did 50 micron and 80 micron particles, and you could see the larger ones. I can't quite relate to it because it's so small, but how big do you think in general are the particles that occur during embolization? So when we're doing an angioplasty, is it a whole range of sizes?
Our previous paper says that Doppler guide wire can detect 300 micrometers, but that can occlude only perforators. But in the real world, much smaller size of embolic particles are liberated. In the previous studies, another previous studies, the major embolic particle size is ranging from 15 to 100 micrometers.
Got it. So you were able to find the ones that were 50, but then what did you do with people with myocardial infarction then? Tell us about what your actual study was with humans.
In the patient with acute myocardial infarction, we can count such kind of small particles just after the coronary intervention, just first balloon inflation and deflation, and just after the first stent implantation.
Got it. So that's what you did. You actually measured with a Doppler guide wire, balloon angioplasty, stent, and deployment. When did you see the most emboli occurring?
Most embolic occurs after the stent implantation.
So with deployment. And then were you able to correlate the number of emboli particles with any measurements?
Many doctors believe that number of embolic particles should be huge, over the 100 and 1,000. But in the real world, the number is not so huge. Range of 10 to 20 to maximum is 100. Not so large number of embolic particles. But 95% of patients show such kind of embolic particles.
Got it. And so you were able to find these particles, see them, and relate them to, I think, TIMI frame count and function. So in the last few seconds, wrapping up here, what next? What study will you do next, potentially, with this topic?
My major result of our paper is that in the patient with large number of embolic particles showed slow flow just after stent implantation. And we can predict this. Some patients shows some number of embolic particles just after first balloon inflation and deflation. In the patient with large number of embolic particles after first balloon inflation shows large number of embolic particles after stent implantation. So we can protect such kind of embolic burden with distal protection in selected number of patients.
Got it. So this would be something interesting then for future studies if we were using emboli protection devices or different drugs to actually use your data from the Doppler guide wire. Well, thanks again. That was a most interesting review of the topic.